we're very grateful to have Dr. Rabie with us from the Informatics Systems in Cambridge. He's a lead data scientist. He's going to talk to us about data sciences. And before I give him the platform, I just wanted to highlight a concept about data sciences. It's all about using algorithms and mathematics to actually enable the knowledge and give insight into the knowledge from structured and unstructured data here. And it's all about gathering the information of the data and then enabling the machine to process the data to come up with the decisions or the knowledge that we have here. If Dr. Rabie just permits me, I just want to highlight this element through a quick kind of a slide. I don't know if you can see my slide.
Okay, shall I stop?
Yeah, please go ahead. Sorry. Yeah, please go ahead, Dr. Rabie. I was trying to highlight the image of data processing, but it kind of lost your presentation in the meantime. Do you mind resharing your slides?
Okay, all right.
Yeah.
Is that okay?
Yeah, thank you. We can see the slides now.
Yeah. All right, shall I start then?
Please go ahead.
Okay, thank you very much for the invitation, Professor Alam. Thank you, Dr. Mohamed, for the introduction. Yes, today I will talk about a sort of buzzword that is called data science, which is a trendy, let's say, a trendy field. It's not new, but we are talking about it too much the last, let's say, five years. But because, you know, when business and marketing is stepping into science, it starts creating terms that are a bit far of being objective. So today, what I'm presenting is the basic or fundamental concepts that we need to understand and some sort of buzzwords that we need to grasp as well. It's an international trend, not only for research companies, but also for governments. And actually, there are so many countries in the 5 continents that started making their own strategies for the so-called industry version 4, including, I mean, which comprises data science, artificial intelligence, etc., etc. And as you can see here, actually, I mean, a lot of countries started something. I mean, started a sort of vision to see how they can make this transformation or digging into this new era of technologies. Even African countries, like, for example, Kenya here. I don't know if you can see my arrow. Kenya started this in the early 2018, then Tunisia, and so many countries started this. I mean, this is in terms of strategies, but also in terms of data. There is a platform or a program that is called the Open Government Partnership, which is a sort of platform helping governments to create better, let's say, better data. We'll see in the end of this presentation, what does it mean to have good data, actually? I mean, let's say better data to facilitate accountability, sharing data, reusability, etc., etc. And as you can see here, actually, still in Africa and Asia, I mean, of course, we understand why for China this is not an option, because they prefer to have their own ecosystem. But mainly Europe and the Americas are into this, either by developing action plans or even implementing action plans. I mean, and in Africa, I mean, there is again, Kenya, Tunisia, Morocco. Uh, yeah, I mean, that started as well implementing action plans to make their data, let's say for now, better. All right. So let's start with some fundamentals first. So here we are talking about data science, which is supposed to be now the umbrella for so many other buzzwords, including AI, machine learning, deep learning, big data, etc., etc. However, you can find so many, let's say, diagrams that are explaining somehow the relation between these different fields and words. But let's start from the very, very beginning. We are talking about data science. So let's start with data. And let's start maybe with some etymology that will make it maybe better to understand. So data actually is the plural of data. I know the term is not used in English anymore, but it used to be used. And is coming from the verb Latin dare. Dare means give. All right. So basically, data or are, since it is plural, are provided things. We don't need to make any effort to receive them, to perceive them, things that we can perceive. But for better definition, it's an association between a thing, when I mean a thing, something that exists, all right, and a symbol. A symbol means something visual, so something we can see, something we can hear, something we can feel, something we can perceive in general and we can sense. So which means actually it is a form of virtuality that could be perceived. Either, I mean, whether we could make a sense of it or not, it is something, it's a meaning, it's some sort of meaning. I mean, we could understand it or not, that is another story, but it's some sort of virtuality, some sort of meaning. And this thing started with when human could give names to things. When human actually started associating, let's say, a voice to an animal, because they can hear that the animal is making that sort of sound. Let's say calling a bird like cuckoo or something like that. And as you can see here in the picture, actually, it all started from human, and then anything else is associated with data, because we simply name things. And it seems to be a peculiarity for human, actually. And this is a huge step into civilization, and that could maybe separate us from the animal kingdom. So whenever I see something or I can perceive it, that's data for me. As soon as I can make sense of it, and I can translate it in a form of news, it becomes information. As you can see here, information is simply a collection of data that can take the form of news. Let's say, for example, A exists, or the population of the UK is, I don't know, 70 million people, right? It's something that could be true, could be false, or could be true to some extent, or could something that we can make a decision about. And then if we go higher, we can build knowledge, and that is by associated sets of informations in a sort of causality or correlation. Let's say, for example, here, if A exists, then B exists as well. So you can translate it into a rule. which means, for example, when and I say you can translate it, it doesn't always comes in the form of a rule. Let's say, for example, magnets, let's say, attract iron. This is a rule as well, because you can say, if I have a magnet, I have a piece of iron, then there will be an attraction between them. So you can translate it. As you can see here, so the first step, the first level is data, then information, which is a collection of data, and then knowledge itself, which is collection of information linked with causality or correlation logic. There is a process that allows us to generate more information. For example, for example, with this case, I know that A exists or exists, and I know as well that I have a rule saying if A exists, then I should expect B somewhere. And now I know that A exists, so I can infer simply that B exists as well. So this inference is when you mix here a piece of knowledge, a piece of information, you might get new information. All right. To summarize this, you can think of it in this form of taxonomy. You have a big circle of data. As soon as we can make some sense, or we can understand the meaning of some collections of them, we get into the blue circle of information. As soon as we can understand the mechanisms or the law or the rules that are governing relations between these pieces of information, we get into knowledge. All right? And of course, we can generate after that more blue things. I mean, more information, I mean, using the inference process. So this is data. Okay. And now, so we are in the topic of data science. So what is maybe data science? All right. So I will start maybe from the etymology of things. So we saw what data is in terms of etymology. It is something given, something we can perceive, some sort of virtuality. Science is from scientia or scientia from Latin, and the verb is scere, which means in English to know. Okay. And now data science is used as umbrella for all the terms that you would consider as technological new terms. Artificial intelligence, machine learning, big data, data analytics, data mining, etc., etc. However, you can find some different Venn diagrams that overlap in these different terms together. But when you say data science, you could, if you have a data scientist or a team of data science, they are expected to work on all of these things. So what is it? And since we are talking about science, here we are talking about objective methods, measurable methods, something that is far away subjectivity and, let's say, personal opinions. And to do that, your team should be able to handle three things, or what I like to call three languages. The language of the universe, that is comprised in maths, statistics, etc. The language of machine, computer science, software development, etc. And then the language of business. It could be biology, it could be journalism, it could be politics, etc., etc. Handling these three languages or these three sort of expertise it means that you can do data science. You can do data science, which means applying objective and scientific ways and methods to transform your data to good shapes and to extract insights and knowledge from them. Remember the knowledge, these pieces of insights that are some sort of rules explaining what is governing relationship between data. As you can see here, there are like binary intersections between each two fields. For example, if you do computer science development, etc., algorithmic, and math, so you can be able to devise new machine learning methods. Traditional research is based on knowledge in a specific domain, as well as knowledge in statistics and maths. And of course, for software development, a software developer should know the minimum in the field where they should develop some sort of software. Okay? So what can we do with data science? Why do we need that? I mean, basically for three main things. First, we have three goals and two sort of actions we can do. The most tyrant action is data transformation, what you can see here in red. And this is taken in the best cases or the worst cases, depends how you look at it. 50% of the effort, sometimes is 90% of the effort. When you need to transform your data, for example, you need to make a lot of transformation even before, for example, reaching some goal of, I want to know if this customer would be solvable if I give them some loan or not. If this customer would buy something. There are plenty and a huge amount of transformation that needs to be done for that. So this is the fastidious part of it. So data transformation is one of two actions. The other one is knowledge discovery. And here, remember the term knowledge, because here in data transformation, what I'm doing, I'm taking data, which is a set of informations, and I'm transforming it into a different shape of information. But now what I'm doing is I'm extracting knowledge, not only bare information or simple information, but knowledge. And that is the task of knowledge discovery, which could be done with machine learning, artificial intelligence, etc. Why do we do this? For basically two things, and the third that could be based on the two. So these two objectives are descriptive knowledge, which means I don't know what is my goal exactly, but I want to understand what is going on there. Let's say, for example, the distribution of age, the different subgroups in some sort of community, the different communities that are using, for example, social media in a given country. I want to understand what is in there, which means I go from the level of the a particular person to something higher, to a group of people, from instance to a group of instances. That is the descriptive knowledge. The predictive knowledge is more granular, which means I want to label, to give a label or to predict a label to an individual. I want to know if they are left wing or right wing. I want to know if they will be solvable or not. I want to know if they are interested in this movie, in that product, etc., etc. Both descriptive and predictive can allow people to make prescriptive knowledge, and that is when you have, for example, a problem. So you do your descriptive knowledge, descriptive work, predictive work, and then you want to resolve some sort of, for example, you want to predict areas where criminality, there is a high level of criminality there. And there, based on that, if you know the rules, because knowledge means models and rules, if you know them, so you can understand why there is a high level of criminality there. So the prescription here is trying to break or destroy the triggers of the thing I'm investigating. All right. So how can we extract knowledge? And that is basically using the so-called artificial intelligence, um, which has as well three levels. The level of, let's say, classical artificial intelligence, which is some sort of copy or fake copy of the human behavior, which means I have a seed of knowledge that I inject into a machine, and then the machine should behave based on that. I have a seed of knowledge. Without that, I can't start with it. All right. Let's say, for example, I have a machine that should do some sort of action based on some sort of conditions, and that is why here I've written. So you have seed of knowledge that is necessary, and from it you can generate new information here. K for knowledge, I for information. You can generate information, and when I say information, it could be an action as well, or a decision. I mean, information is the umbrella for action, decision, or anything that could take the form of news. Or if I can do some reasoning, let's say A implies B and B implies C, so I know that A implies C. So this is the very classical artificial intelligence, all right, which requires an injection of a seed of knowledge, a set of rules. From that set of rules, more rules could be built, and more information and decisions could be built as well. I don't know how much time I have. Do I still have some time?
You
Not
still
very.
have 10 minutes, roughly.
Oh, okay. All right. I still have 10 minutes.
Sorry, yes, 10 minutes, just under 10 minutes.
Okay, yeah. So, and then machine learning. In machine learning, actually, we don't need to have any sort of initial knowledge. We don't need to have any sort of initial rules. We just need an algorithm that is external, and then I have a set of information, and then I generate models. All right. Deep learning is more specific because we don't even have sensible or meaningful information. We have only data, and then information is built, and then knowledge is built upon that. Is more specific. So what is big data? And I will try to do quick here. Actually, maybe some of you heard of the 3 V's or the 3 dimensions of big data. And they said that we can talk about big data when we have big volumes of data, varied and complex, structured and unstructured, etc. And it could have 2 forms of velocity. It could come in form of batch or in form of streaming. And okay, 3 dimensions, they all start with V. What a coincidence, actually. Though this is okay, but some other people want to be more innovative. So they said, oh, okay, let's add veracity. So it's not 3V, so it's 4V then. And veracity is how accurate the data is. It seems like here a battle of V. So we are getting into this kind of pseudoscience that is more about impressing how I can express things. And of course, you know the rest, or maybe not. Then we have 5 Vs, 6 Vs, 7, 8, and now we have 16 Vs. And guess what? They are all Vs. You know, actually, viscosity, visualization, come on. In the end, what is there? What can we get from this buzzword? We don't need to care about these Vs. We got some sort of idea. It's simply maybe this. Big data are data that have a scale, diversity, and complexity that require new approaches, new hardware. This is it. It's something that is bigger than my capacity or the capacity of my facilities to handle it. And now, when talking about big data, we are talking more of technologies or new approaches that are handling these data rather than describing how the data should be and the different V's of these data. And just to give an example, Hadoop ecosystem is the most adopted stack or package of big data technologies that is widely used now. Data and decision. I'm going to be quick. There are so different ways to take decision. Using democracy, using dictatorship, using balance, using based on your finance, asking customers, etc., etc. But we'll always find people like this. These gods of knowledge, they know they're right, okay? And it's better to not argue with them. But you will find as well other people like this wise man who said, without data, you are just another person with an opinion. And this is it, actually. This is the point. To be just here to introduce the term of being data-driven. I make my decisions based on data, that's it. It's not a question of ego, but somebody else made it more, made a good compromise maybe. If we have data, and this is one of the former CEO of Netscape, he said, if we have data, so let's look at the data. If all we have are opinions, let's go with mine, okay? So maybe it's a good way as well to do things. In the end, how to be data-driven, because you will find so many things that are saying, okay, this is data-driven company, etc., data-driven solution. What is that? Basically, people who do the sales don't know what being data-driven is. It is simply this: analyzing data, getting insights from data, taking action on the light of these insights. And then there's something very important here. I need to have a trace. My action and my decision should generate new data. And then I go and I make my loop. And this loop will always get better with better insights, with better decision, etc. Like a baby learning. This is being data-driven. I will finish with this. If we need to be data-driven, we need to make things digital, and we need to dig and dive into digitalization. And I will speak here about the FAIR principle of data management. So maybe, I mean, there are 3 terms that are used interchangeably in this concept of digitalization, which is digitization, and digital transformation. The first one is the process of making data in digital format. The second one, which is digitalization, is making processes digitalized and smarter, like using artificial intelligence, machine learning, etc., etc. So the first one is about data. The second one is about processes. The third one is about the business itself. Does the business, is it using data and technology to sell, to get feedback, etc., etc. But because I said here, where should we start? We should start here in digitization thing. How can we transform data into digital format? What format? How? And for this, we need to use the FAIR principles. And this is a concept that appeared in the scientific community, actually, and it stands for Findable, Accessible, Interoperable, Reusable. All right. But then it got into business and etc. And even actually, people are not still familiar with this concept or these principles, because, for example, here, even in research, they asked 750 researchers, and only like 150 of them are familiar with the concept. So let's get into it. And remember, in the beginning, I said that that platform, OGP, that is helping government to create better data for more accountability and more efficiency. Here we need to separate between two things. When we say fair, that doesn't mean open. Of course, if data are open and fair, this would be very, very nice. But data could be fair and not open, could be open and not fair, and could be both, and could be neither fair and neither open. All right. Still, what is fair? Okay, I'm coming to it. Is here. So findable, accessible, interoperable, reusable. Findable means that each entity, each data point should have an ID. This data thing could be a code, could be a client, could be whatever, but it must have an ID at least. Accessible, there must be a protocol that is used so I can get this from its repository. It's accessible. And then interoperable means that it has a format that is standard. It is in Excel, JSON, CSV, but not Word and Excel and these kind of vendor formats. And then reusable is simply with all three first, findable, accessible, interoperable, and with extra and more metadata and description. Here, maybe you can see the colors. Actually, colors are meaningful here because yellow means metadata. This burgundy thing here is about protocols. The red is about format. So is making data well structured with IDs in good format, standard format, accessible via like normal protocols like internet, etc. And in the end, richly described. So this is good data. So there is a process to do this, but I will skip it for the time. But I will finish with this, which I just said. In the end, getting into digital and getting good data so that you can make the best of data science is to create objects, data objects like this. So if you see here in the kernel, you have the data, the digital object itself. It could be data, code, or whatever things, any sort of data. They all should have identifiers. They all should be in standard format. And in the end, richly described, like I just give an example. For example, the ID is I don't know, a string of 15 characters, and it starts with, and it has this reveal expression. That is some sort of metadata. If we have this, we get good data, easily transformable, easily reusable in so many cases.
Thank you very much, Dr. Rabie. That was very insightful in terms of data sciences, and you've linked it to the previous sessions in terms of Industrial 4, and then you mentioned about the government operational processes, which was quite interesting. And then you actually helped us link between the knowledge element and the information and the data, and that was very important for us to distinguish between these three layers to then start looking at the business elements, the math elements, and the computer elements, and how the different facts of life or different trades will have their own languages in terms of universal languages for mathematics or machine learning for the computers. And then there's the business terminologies that we have to encompass in everything else. And that brought us into analyzing this sum of data in terms of artificial intelligence, in terms of machine learning, in terms of deep learning, and what does each one of these concepts mean to us here. And then you gave us the concept of the V's that kept growing from 1 to 4 to 5 to 8 to 16, I think was the last one you left us with. And then you gave us a link between data, insight, and action, which links into what we were trying to do in terms of the knowledge and in terms of Industrial 4 earlier on here. And then you gave us the 3Ds in terms of digitizing, digitalizing, and data infrastructure and analysis. And then you brought us into the FAIR model and how the FAIR model can encompass all the elements in terms of what is the data, what is the quality of the data, is it structured, is it unstructured, how we use it and how we apply it. And it's been very, very insightful for us to actually get to know what we talk about when we mean data. Because all of us kind of think, you know, we use data in real life, but you've actually brought it home to actually give us an understanding. And I'm getting an array of questions popping in through here, okay? Can you give more light on the difference between digitizing and digitalizing, please?
Okay, so actually digitizing is related to data itself, and that is the last part and the part that where I focused more on how we do it, is focused on data itself. How we can is the overhaul or the recast of data to make it like easily reusable. Is the process of refining data to make it ready to use with the less of transformation later on if I want to do something. So it's focused on data. Digitalization is more focused on processes, which means if I want to predict something, if I want to predict an association between, for example, a problem, okay, and some category of people, what sort of algorithm should I use? So is making this, let's say, based on machine learning and data driven in a way. Each time I try to get this insight, I need as well to measure how wrong was I, my error rate, and then go back and refine it. Is about the process itself, how to get insights from the data that was previously digitized. So it's about the process itself.
Okay, thank you very much. There's a message here from Dr. Alam, but I don't understand it about curfew time. Can you elaborate on that, Dr. Alam? You're muted, Dr. Alam.
No, sorry. This is a message actually from Professor Joseph Natai from Uganda. He is going to leave us shortly because of the curfew of the timing, you know, because of the time difference. So
Okay.
I just suggested to give him 1 or 2 minutes just to say a concluding remark. You have been, Professor, an outstanding contributor to this conference. Yesterday, your talk, your continuous discussions throughout the conference has been amazing. So I think if with your permission, the moderator, if you give Professor Joseph just a few minutes to say a few remarks before he leaves, because I think you have to leave, otherwise you'll be locked in the university.
Please go ahead, Dr. Joseph.
Thank you very much, Chair, and thank you very much, Professor Mohamed, for giving me the opportunity to join you in this conference and also to be able to make some few remarks relating to the subject that I presented yesterday. And for me, I must say this is an honor, and it's really an honor that I didn't take lightly, but the opportunity in joining you and attending more of these conferences whenever you organize them. And I really want to make many new friends and collaborate in the various areas of research that we are undertaking to be able to contribute towards this planet. And that's what I can say. But thank you very much for extending the opportunity.
Thank you, Professor. Thank you very much. And we're really been very pleased. And we will continue. Definitely, we'll come back to. I have always said this before. Many times I said I gave you 2 days ago as an example to the Sudan Ministry of Higher Education as distinguished academics in Africa working very hard, not just to write papers or teach students, but to get engaged. And I think you have been very much engaging, and I really hope we have lots of aspirations for your engagement in the future. Thank you very much, and I wish you and all the people in Uganda all the best. I hope we all get out of this COVID safely, and thank you very much for your contribution. So the chair is back to you.
Thank you very much for that, and thank you, Professor Joseph, for all your contribution. Coming back to Dr. Rabie, can you give us an insight from the data science point of view about structured and unstructured data?
All right. Basically, actually, talking about structure is we can take two things, two references. Let's take the machine and the human. All right. When we get closer to the machine, data becomes more and more structured, simply because I can create any program to read the data. So this is the point. When it gets closer to human, that's the big mess. So we get free text of all sorts of things. And actually, I've been working in one of the field, I mean, or let's say on biology data, and I can tell you is a suffering, because biologists, for example, like to write, let's say, gene functions and etc. in their own way. And everyone has this sort of ego to not change the way they describe the function. Of course, the community in the end try to resolve this battle by creating some sort of vocabulary, standard vocabulary, which would make data get closer to the structure format. But still, in many other areas, data is still free text. We like to express things in our ways. And if, for example, we see when people use a lot of adjectives and these kind of, I don't know how is it called in English, but style of expressions. I don't know if the term is correct in English. These kind of style of expressions to say things. Yeah, but sorry, the machine doesn't care about that. So when we have that, we are talking about unstructured data. We don't have data points, and each data point has a given number of, or a known number of attributes and criteria. So yeah, so this is it actually.
It's very fascinating because there's all elements to do with the data. Even the quality of data that you have, I'm sure, has an impact on it, because not all data is relevant data. I'm sure, as all of us will say to our students when it comes to simulation and other things, what you put in is what you get out. But does it mean it's the valid information?
Garbage in, garbage out.
But yeah, I didn't want to say it because of the platform here, but yeah, rubbish in, rubbish out, basically. I say to all my students on all simulation, unfortunately, you need to analyze the source of data when you're talking about the data. The value of information of the data is very important. And when you have a technical element, a financial commerce element associated with this element, if you don't get the data right, what you predict is a false model that's based on a false economy of scales and false predictions, which means a failure of your PhD, if you want to call it that, basically.
Absolutely, yeah.
So it's very important to analyze these things here, and we try to drive the point home in terms of it's not just the data, it's about refining the data, it's about iterating the data. There's the statistical knowledge, there's the R values and other things like that. They're all universal languages that you've talked about. And then you start moving it towards the assemble model, or in our cases, we move it towards the governing principles in terms of this pressure, volume, and temperature as a basic entity, and then we build up into it. And as you said, a biologist point of view and a chemical engineer point of view, we have our own language that we describe things to, and unfortunately the machine doesn't recognize these languages for us or the abbreviation. So it's training the machine and training and developing the unified vocabulary to refine the data to then to analyze the system is very important.
Actually, for anecdote, actually, I had a little argument with one of the chancellor of the, let's say, prime ministry in Tunisia, because they are trying to create a system to track all sort of, let's say, all sort of money flows and if there are corruptions and stuff. The thing is that I asked them that there's some text, some legal text, for us to get knowledge from them, we need to force some sort of format for that. And she said, no, but the way of writing these legal texts is an art. We are not given this. Yeah, but I told her the machine doesn't care about art. We can put that in the museum, but not, we cannot give this to the machine, actually. Yeah, I mean, so it's as well a battle of making people understand this, because I understand why people don't like this sort of dry information without soul, as they say, and stuff.
Yeah,
We need some some let's say spell of art or yeah, you know.
yeah, no, I appreciate that. I mean, from the data point of view, that this is what we were trying to do throughout this session when we talked about it, from Deming saying, in God we trust, but all others must bring data to them, to then trying to link it to the sustainability and other things like that. When we define the knowledge management aspects and what is knowledge in terms of the Dr. Rawad's presentation, and then we took it to Dr. Ahmed's presentation in terms of the application with the Internet of Things and the Internet of People and how everything integrates, we realized that the value of data is very important, the value of information and the data shared. If we're moving this artificial intelligence from a simple calculator, you put an input, you get an output, to a group of autonomous vehicles communicating with each other, to then you know, a psychology kind of behavioral organizational system, as we're trying to do with the Industry 4, to move to then a self-recognizing, self-governing IT or artificial intelligence systems that behave or mimic a human, is very important to refine the data. It's very important to realize that there's a limitation and the data always controls everything. So at this point, I really thank you very much. It's been fascinating to listen to all of you in terms of the knowledge, the industry applications, and you've enlightened us in terms of what is data sciences in a broader sense today. And thank you very much. And I hope you can share your PowerPoint presentation with us at some stage or another.
So please remember, if we all help and do a little bit, it will make a big difference.